So you guys are looking at the transformations of parent functions, which means taking a function and moving around, switching it, sliding it, flipping it, doing all the stuff to it. Okay? All a parent function is the most basic of a certain shape. We worked in class the other day with, say, parabolas, which look like this. What kind of equation gives you a parabola? Adrian?
X to the second.
Exactly. X to the second power gives you a parabola. Okay, and there's a lot of them that you are working with. So for instance, a V shape is the absolute value of x. You could have a square root. The square root of x looks something like that usually. So just the idea of parent functions, and it's going to work with anything. Yes, Asia? Yes. So we have an absolute value function up here, which automatically means to me that I'm using a V shape. So I kind of draw a little V. Okay? So the parent is actually the absolute value of x, and you could just write absolute value here. Now, here's the deal for transformations. Right now, I think you're just moving on what's called a vertical shift, like moving something up and down, and a phase shift, or a horizontal shift, which is left and right. So that's all these numbers here do. Okay, we worked on the calculator the other day. If I do something to the end of the function, like -2, does anyone remember what that does to the function? Doesn't flip it, yes.
Does it move it?
It moves it. Yeah.
Or right.
We have left or right, and the
Up or
other
down.
up or down. So we have 4 possibilities. Make a good guess here.
I would say flip the opposite.
I'd say go left.
This will go. So here's the thing: the last number, the very end, is going to be an up or down. So it's going to be an up or down. And how do you know it's going to go down?
Because it's negative.
Because negative, it's going to go downward. So I just take the usual V. So here's my parent function. Here's my typical V shape. I didn't do a great job graphing it, but I'm just sketching it on there. Okay? And I'm going to move that down 2. So now my little point, the vertex of the V is right there. Okay? And then I have to look at this in here. If the one at the end moves it up or down, what do you think the number inside the absolute value does?
It goes left, right.
Left, right. So this is going to move it left or right. Left or right. Now the thing that's usually confusing about this is since which way is usually positive, left or right?
Right.
Right's usually positive, but when we have it inside,
Go flip it.
it's the opposite direction. So this is actually going to go to the left. To the left, to the left. So that one will go left 5. So this says we go down 2, left 5. 1, 2, 3, 4, 5. And now that's just our new vertex for our V shape. So this is just moving down to left 5. Absolute value always has a slope. The basic has a slope of 1. So it has a slope up and over by 1s. Up and over by 1s. And that's your new graph. And for transformations, you would just say shift. And other teachers might use different words. They might say translate, transform. But I just say shift down 2 and left 5. And that's it. Okay, this time we're working backwards. We just want to find the equation. So here's the thing. Our square root equation usually looks like this. I'm not sure if you guys use f of x.
Yeah, we do.
Or use y.
Sometimes it's y.
I'll go f of x equals square root of x. Okay, so we just said this a second ago. If I want to shift this down 2, what am I going to put at the end? I want to shift it down 2. So minus what?
2.
Minus 2. That's got to go at the end. A minus 2 at the end. Okay? How did I move it left and right again?
You do put a parentheses.
It's got to be inside of our function.
Absolute value.
So it was in the absolute value, but this is a square root. So I want to put it under the square root. And if I want to move it left 7, what would I put under the square root? Now you think minus, but remember it's opposite.
Oh, yeah, no.
So it'd be plus 7.
She told us so yesterday.
And that's it. That's your answer. You just put f of x equals square root. Again, it'd be x plus 7 because you're left 7. And down 2 is a minus 2 at the end. Okay? Last one. We have a quadratic now. Now here's the thing, Anthony. Here's our usual quadratic. Our usual quadratic looks like this. A quadratic is just our parabola. Where's that vertex right there? What is that point right there?
0.
0, 0. That's the origin. So now, if the new vertex is at negative 5, negative 2, that's our new vertex. How do I move from here to there?
Down 2 over 5.
Down 2 and over 5. So I actually am going, this is telling me, and I'll just put the little thing here. This is telling me to go down 2. That's what this negative 2 is telling me.
Over.
And this is telling me to go left 5. Very similar to this problem up here. It's a quadratic, so like what Asia said earlier, that's an x squared, right? That's an f of x.
I said what?
You said that parabolas, that curves like this, are x to the second power.
Oh, yeah.
So that means I definitely have an x squared graph, f of x equals, I do have an x squared. Now how do I move that down 2? Put a minus 2 at the end. Ooh, and this is kind of tough because I already wrote it there. How would I put a left 5?
Add 5. Or add, yeah.
I got to add 5, but the thing is it has to be in parentheses underneath the squared. So I have to put like a plus 5 in here. So I'll write that up here now, all in one. We have an f of x equals parenthesis x plus 5 quantity squared minus 2. And that's our answer. Question there.
Just sign it.
Thank you for telling me that, Patrick. I appreciate it.